1944. The ground near the Italian town of Cisterna is soaked and broken, turned into mud by weeks of artillery fire. A low winter sun hangs behind clouds of smoke, turning the battlefield into a gray, flattened world. From behind a hedgerow, a German anti-tank gun fires. The round strikes the front of an American M4 Sherman at close range. Steel shrieks. Sparks burst outward. The impact echoes across the field. The German crew waits for flame. It does not come. The Sherman lurches, its suspension sagging for a moment, then steadies. Its engine keeps running. Tracks grind forward again, slow but deliberate. Inside, the crew is shaken, ears ringing, but alive. A loader wipes blood from his lip. The gunner recenters the sight. Seconds later, the turret swings, and the American gun fires back. Across the line, German soldiers stare. They had seen French tanks burn in 1940. They had watched British armor collapse in North Africa. American tanks, they believed, would be no different. Lightly armored, poorly designed, easy kills. But this one did not die when it was supposed to. And it was not alone. As more Shermans appear through the smoke-scarred, dented, still moving the battlefield begins to reveal a truth. The German army had not yet fully understood, a truth shaped not by perfection but by persistence and by a war that was about to be fought very differently. By the time American tanks began appearing in large numbers on European battlefields, the German army had already spent nearly 4 years at war. Those years had shaped not only its victories, but its confidence, especially in armor. From the opening campaigns of 1939 and 1940, German commanders had come to believe that the tank was not simply a weapon, but the central instrument of modern war. In Poland, fast-moving panzer divisions shattered an army that was brave but structurally unprepared. In France, German armor sliced through the Ardennes, a region Allied planners had considered impassable to tanks. French heavy armor, in many cases technically superior on paper, was defeated not by weaker machines, but by speed, coordination, and doctrine. German tanks move with infantry, artillery, engineers, and air support. Radios were standard. Orders flowed quickly. Decisions were decentralized. The battlefield bent around mobility. This early success forged a powerful institutional belief inside the Wehrmacht. Armored warfare was a contest of technical quality and tactical finesse. German tanks did not need to be numerous if they were well-handled and well-built. The Panzer III and Panzer IV, though modest by later standards, were reliable, easy to command, and adaptable. They won not because they were invulnerable, but because they were used correctly. As the war expanded eastward in 1941, this confidence was tested. Operation Barbarossa brought German armor into contact with the Soviet T-34 and KB-1 tanks that shocked German crews with their sloped armor and powerful guns. For the first time, German shells bounced off enemy vehicles at normal combat ranges. Losses mounted. Reports reached Berlin describing machines that could not be easily destroyed. The German response was not to abandon their faith in technical superiority, but to deepen it. New designs followed: heavier armor, larger guns, more complex machines. The thay entered service in 1942, mounting an 88mm gun capable of destroying enemy tanks at long range. The Panther followed, designed specifically to counter the T-34. These tanks were formidable. On open ground in the hands of trained crews, they dominated. But they came at a cost. They were difficult to manufacture, difficult to transport, and difficult to maintain. Mechanical breakdowns were common. Spare parts were limited. Recovery vehicles struggled to tow them. Fuel consumption was high at a time when Germany's oil supplies were shrinking under Allied bombing. Still, within the German armored corps, these problems were often treated as secondary. The battlefield remained the primary measure of worth. By contrast, American armor was viewed through a lens shaped by early encounters and long-held assumptions. The United States entered the war late. Its army had not fought a modern armored war against a peer opponent. German officers reading intelligence summaries saw reports of American industrial output and dismissed them as theoretical. Factories, they believed, did not win battles, tanks did. The first American tanks encountered in North Africa reinforced this belief. Early U.S. units arrived inexperienced. Coordination was uneven. At Kasserine Pass in February 1943, German forces under Erwin Rommel exploited these weaknesses. American armor was outmaneuvered, isolated, and destroyed. German after-action reports spoke of poor tactical handling and thin armor. The conclusions were predictable. American tanks were seen as crude, overproduced, built for speed and ease, not combat. The M3 Lee, with its high profile and side-mounted gun, was ridiculed. Even the newer M4 Sherman, which replaced it, was often described in German documents as undergunned and inadequately protected. Compared to a Panther or Tiger, the Sherman appeared inferior in every measurable category: gun caliber, armor thickness, silhouette. German crews joked that American tanks burned easily, that they exploded on impact, that they were machines for amateurs. In 1943, these assessments felt justified. In Tunisia, German anti-tank guns and panzers destroyed Shermans at range. In Italy, mountainous terrain and narrow roads limited American maneuver, exposing tanks to ambush. Yet beneath this confidence, something subtle was beginning to shift. The Americans did not stop coming. Losses that would have crippled other armies were replaced within weeks. Destroyed units reappeared with fresh vehicles. Damaged Shermans were recovered, repaired, and returned to service with remarkable speed. German crews began encountering the same units again, machines bearing weld scars, replacement panels, and new track links bolted over old damage. The war was changing shape, and the battlefield was about to test not just which tank was stronger, but which system could endure. The American approach to armored warfare had been shaped far from the battlefields of Europe. It began in design offices, training manuals, and factory floors thousands of miles away, where war was studied not as a single decisive clash, but as a sustained industrial struggle. For the United States, the central question was not how to build the most powerful tank, but how to build enough tanks to fight a global war and keep them fighting. The M4 Sherman emerged from this philosophy. Designed in 1941 and standardized in early 1942, it was not intended to duel heavy enemy armor head-on. American doctrine placed tank versus tank combat as a secondary mission. Enemy armor, according to U.S. field manuals, would be dealt with by tank destroyers, artillery, and air power. Tanks were meant to exploit breakthroughs, support infantry, and maintain momentum. This shaped every aspect of the Sherman's design. Its armor was adequate, not excessive. Its gun, initially a 75mm, was chosen for versatility rather than sheer penetration, effective against infantry positions, field fortifications, and lighter vehicles. The turret was roomy, allowing crews to work efficiently under stress. Radios were standard, ensuring communication between tanks and with supporting units. Perhaps most importantly, the Sherman was mechanically reliable by the standards of the time. It could be driven long distances without constant maintenance. It could be repaired in the field. Parts were interchangeable across variants. American factories produced Shermans at a pace no other nation could match. By mid-1943, thousands were rolling off assembly lines every month. They were shipped across oceans, unloaded at ports, and driven straight into combat zones. This scale of production was not an accident. It was the foundation of U.S. war planning. Early battlefield results, however, did little to impress German observers. In North Africa, Shermans faced experienced German crews armed with long-barreled Panzer IVs and 88mm anti-aircraft guns used in an anti-tank role. At typical engagement ranges, the Sherman's armor could be penetrated. Fires occurred, crews were lost. German reports noted that American tanks often advanced boldly, sometimes recklessly, exposing themselves to fire. What these reports often failed to note was what happened next. American recovery units worked under fire to retrieve disabled vehicles. Tanks that were not completely destroyed were towed back, repaired, and returned to the line. Crews were rotated, retrained, and reinforced. New units arrived with better coordination, improved tactics, and hard-earned experience. By late 1943, the American armored force fighting in Italy was no longer the one that had been bloodied at Kasserine. The Sherman itself evolved. Improved armor layouts reduced weak points. Wet ammunition stowage was introduced, dramatically lowering the chance of catastrophic fires after penetration. Later variants mounted a more powerful 76mm gun capable of defeating German armor at practical combat ranges. British modifications, such as the Firefly, mounted the formidable 17-pounder, giving Allied forces a weapon that could destroy Tigers and Panthers. Yet even with these upgrades, the Sherman remained on paper inferior to Germany's heaviest tanks. German crews still expected easy kills. They still believed that one well-placed shot would end the fight. The battlefield began to contradict them. By 1944, American armored units were no longer operating in isolation. They advanced with infantry trained in close cooperation, engineers clearing obstacles, artillery firing on call, and aircraft circling overhead. A German anti-tank gun that revealed its position might destroy one Sherman, but it would be answered within minutes by artillery fire or air attack. More importantly, Shermans rarely fought alone. They advanced in numbers, overlapping fields of fire supporting one another. When one was hit, another moved forward. When a tank was knocked out, two more appeared. German crews began reporting engagements where multiple Shermans absorbed hit, some penetrations, some not, and yet the attack continued. This was not the duel the German Armored Corps had trained for. It was attrition, pressure, and momentum, the kind of fighting where individual technical superiority mattered less than the ability to sustain losses and keep moving. The Sherman, once mocked as a crude machine, was becoming something else on the battlefield. A constant presence. And as the war moved toward France, where terrain, logistics, and air power would converge on an unprecedented scale, that presence was about to be tested in the most unforgiving conditions yet. Inside an M4 Sherman, space was limited, but purpose was clear. 5 men worked in close proximity, bound by noise, heat, and routine. The driver and assistant driver focused on terrain and obstacles. The gunner tracked targets through a narrow sight. The loader moved shells weighing over 15 kilograms in a rhythm drilled by repetition. Above them, the commander stood partially exposed, scanning the battlefield, radio headset pressed tight against his ears. Combat inside the tank was sudden and violent. When a round struck the hull, the impact felt like a hammer blow from all directions at once. Paint flakes and metal fragments filled the air. Smoke seeped through seams. The smell of cordite and hot oil became familiar, yet survival often depended not on avoiding hits, but on what happened after being hit. The Sherman's interior layout allowed crews to escape more easily than many German designs. Hatches were larger, ammunition was stowed lower, and, later in the war, surrounded by water-filled jackets that reduced fires. When penetrations occurred, crews were more likely to survive long enough to bail out or fight on. American training emphasized crew replacement and unit continuity. A tank lost did not mean a unit destroyed. Survivors were reassigned. Lessons were recorded and disseminated. Over time, crews learned where to angle armor, how to use terrain, and when to advance or hold. For German gunners watching through optics, the sight was unsettling. Tanks that should have burned sometimes did not. Crews emerged alive. Others kept moving, firing back. The battlefield was teaching its own lessons. German armored doctrine had evolved around the tank duel. Identify the enemy. Engage at range. Destroy with superior firepower. This worked best in open terrain where visibility and long guns mattered most. American tactics disrupted this expectation. Sherman units rarely advanced alone or in neat formations. They moved with infantry, using suppressive fire and smoke to limit enemy visibility. Tanks fired on the move, not always to kill, but to force German gunners to keep their heads down. When the Sherman was hit, others adjusted their positions, flanking the firing point rather than stopping to trade shots. In Normandy, this approach became essential. Hedgerows restricted visibility to a few dozen meters. German anti-tank guns lay hidden until the last moment. The first tank through a gap often took the hit. But that first loss exposed the position. Artillery followed. Infantry closed in. Engineers cleared paths for the next advance. German after-action reports increasingly noted this pattern. American tanks accepted losses in order to locate defenses. Once found, those defenses rarely survived long. The Sherman was not expected to win every encounter, but to enable the next one. This relentless pressure altered the tempo of battle. German units were forced to reposition constantly, consuming fuel and ammunition they could not easily replace. Time, once their ally, began to work against them. Technologically, the Sherman was a compromise. Its armor could not reliably stop high-velocity German rounds. Its guns struggled against frontal armor of Panthers and Tigers, but it incorporated features that reflected a different understanding of battlefield survival. Mechanical reliability meant Shermans reached the fight more often. Where German heavy tanks broke down en route, Shermans arrived on schedule. Standardized parts simplified repairs. A damaged transmission or track could be replaced quickly, often returning a tank to service within days. The introduction of wet ammunition stowage in 1944 reduced fire-related losses by more than half. Penetrations that once would have caused catastrophic explosions now resulted in damaged tanks with surviving crews. These vehicles could be recovered, studied, and improved upon. German intelligence gradually acknowledged these changes. Reports began noting that American tanks were less prone to burn and that their crews displayed growing confidence. The Sherman was no longer dismissed as a disposable machine. It was recognized as a resilient one, not invincible, but persistent. And on a battlefield where survival often came down to endurance rather than elegance, that persistence was beginning to matter more than any single gun or armor plate. The pressure was mounting not just on German positions but on German assumptions. For German tank and anti-tank crews, battlefield expectations were built on experience. They had learned through years of combat what a destroyed enemy tank looked like. Flames, ammunition cook-offs, crews scrambling or not emerging at all. Against early Allied armor, this pattern had been reliable. The Sherman disrupted that certainty. German after-action reports from late 1943 onward began to include unfamiliar language, tanks described as damaged but operational, vehicles continuing advance despite hits, engagements where multiple rounds were required to stop a single target. These were not technical failures of German weapons, but tactical surprises. In Normandy, German gunners often fired from concealed positions at close range. The first Sherman was hit, sometimes destroyed, but the expected pause, panic, withdrawal, collapse rarely followed. Instead, more Shermans pressed forward, firing into hedgerows, buildings, and tree lines. The original firing position became untenable within minutes. Panther and thay crews still achieved high kill counts in favorable conditions, but those moments were increasingly isolated. Ammunition shortages limited sustained engagements. Fuel constraints reduced mobility. Breakdowns immobilized vehicles that should have dominated open ground. Perhaps most unsettling was repetition. The same American units appeared again and again, even after suffering losses. Tanks with visible repair welts returned to the front. Crews displayed coordination that improved noticeably over time. German superiority, once assumed, now had to be proven in every encounter. And proving it was becoming harder. Behind every Sherman on the battlefield stood a logistical system of immense scale. American leadership understood that armored warfare was not only about combat performance, but about replacement, repair, and resupply. Tanks were treated as components of a larger mechanism, one designed to keep moving regardless of losses. Supply depots followed advancing units closely. Recovery teams operated under fire to retrieve damaged vehicles. Field workshops repaired tanks near the front, while factories at home replaced those beyond repair. Crews trained with the expectation that equipment would fail and that failure was temporary. German leadership faced a different reality. Heavy tanks required specialized maintenance and skilled mechanics. Spare parts were limited. Transporting disabled vehicles often proved impossible under Allied air superiority. A Panther lost to mechanical failure could represent weeks of irreplaceable effort. This imbalance widened as the war progressed. American commanders could plan offensives knowing that losses would be replenished. German commanders increasingly planned around scarcity, husbanding fuel, conserving ammunition, and choosing when not to fight. The Sherman fit perfectly into the American system. It was not designed to be preserved at all costs. It was designed to be used, damaged, repaired, and used again. On a strategic level, this philosophy began to outweigh battlefield statistics. Kill ratios mattered less when the losing side could not replace its losses. War is fought as much in the mind as on the ground. For German soldiers accustomed to early victories, the psychological impact of an enemy that refused to break was profound. Every Sherman that kept moving after a hit challenged expectations formed over years of combat. American crews, by contrast, drew confidence from survival. Knowing that a hit did not always mean death changed how tanks were used. Crews advanced more aggressively. Units accepted risk in ways that were impossible without faith in their machines and support systems. This confidence fed momentum. Momentum fed pressure. Pressure eroded German morale, already strained by constant retreat, air attacks, and mounting losses on multiple fronts. By mid-1944, German intelligence assessments no longer mocked American armor. They analyzed it. They acknowledged its reliability, its numbers, and its integration with other arms. The tone shifted from dismissal to concern. The Sherman had not become a superior tank in isolation, but it had become part of a superior way of fighting, and as Allied forces prepared for their largest armored engagements yet, The accumulated weight of this system, human, mechanical, and psychological, was about to collide head-on with German defenses, in a moment that would decide far more than a single battle. June 1944, Normandy. The land itself seemed designed to kill tanks. Thick hedgerows, ancient earthen walls, topped with dense vegetation, cut the countryside into narrow compartments. Fields were small, visibility was measured in meters, not kilometers. Every lane, every gap, every bend in the road could hide a gun. For German defenders, this terrain was ideal. Anti-tank weapons were concealed until the last moment. Panzerfaust teams waited in silence. Panthers and Tigers took hull-down positions, exposing only their thick frontal armor. The first American tank through a hedgerow gap was often doomed. And often, that tank was a Sherman. Direct hits were common. At close range, German 75mm and 88mm guns punched through Sherman armor with brutal efficiency. Turrets were blown open, tracks were shattered. Some tanks burned, others did not. The difference mattered more than German crews initially realized. In the early days after the Normandy landings, American armored losses were heavy. Units advancing inland from Omaha and Utah beaches encountered fierce resistance. German formations, though outnumbered, fought skillfully and with discipline. Individual German tank commanders achieved impressive kill counts in short engagements, but something unusual began to happen as the days stretched into weeks. When a Sherman was hit but not destroyed, it was rarely abandoned immediately. Crews fought through shock and smoke, returning fire or reversing behind cover. If immobilized, they held position, using their gun as long as possible. Infantry rallied around disabled tanks, using them as cover. Engineers moved forward to breach hedgerows under fire. German gunners trained to expect decisive kills were forced to remain exposed longer. A shot that failed to ignite the Sherman's ammunition did not end the threat, it escalated it. The firing position was revealed.
Return fire followed. Artillery coordinates were called in. Aircraft ever present over Normandy were summoned. American units adapted quickly. Field modifications appeared almost overnight. Steel plates, spare track links, sandbags, anything that might add protection were welded or strapped to Shermans. Specialized engineering tanks were developed to break through hedgerows head-on rather than climbing them and exposing vulnerable undersides.
The Sherman became less a single vehicle and more a node in a network. One tank advanced. Another covered. Infantry followed close enough to neutralize close-range threats. Losses still occurred, but advances continued. German commanders noted the change. Reports from panzer units described American attacks as unceasing. Tanks appeared in waves, not reckless but relentless. Destroying one or two did not halt the advance. Destroying five sometimes did not either. By late July, during Operation Cobra, this pressure reached a breaking point. Massive aerial bombardments shattered German defensive lines. When the ground attack followed, Shermans surged forward through gaps that no longer held. German units attempted counterattacks, but fuel shortages and mechanical failures limited their reach. Panther and Tiger crews still inflicted damage when conditions allowed, but increasingly they found themselves isolated, outnumbered, outflanked, and under constant air threat. A single heavy tank, no matter how powerful, could not control a battlefield saturated with American armor, artillery, and aircraft. One German officer later summarized the problem with brutal clarity. The Americans could lose tanks faster than Germany could destroy them. And more importantly, they could keep attacking while doing so. By the time Allied forces broke out of Normandy, the question was no longer whether the Sherman was inferior in a technical sense. The battlefield had already answered that. The real question was whether German defenses could survive a war fought at this scale, where direct hits did not always stop the advance, and where the pressure never truly lifted. That question would be answered in the next phase of fighting, as American armored columns rolled eastward into France carrying their scars with them. August 1944. Northern France. The hedgerows fell away behind the advancing columns, replaced by open farmland, long roads, and battered towns. This was the terrain German armored doctrine had been built for. In theory, it was here at range, with room to maneuver, that Panthers and Tigers should have regained their dominance. In practice, they rarely did. American armored divisions moved with a speed that unsettled German planners. Shermans advanced in long columns, engines running day and night, pausing only long enough to refuel, rearm, and repair. Damaged tanks were pushed aside, marked for recovery, while replacements took their place almost immediately. The advance did not wait for perfection. German units, by contrast, were exhausted. Fuel shortages dictated movement. Panthers were abandoned intact when fuel ran dry. Tigers that broke down were destroyed by their own crews to prevent capture. Air attacks turned daylight movement into a calculated risk. Every delay compounded the problem. When German tanks did engage, the fighting was often fierce and localized. A Panther firing from cover could destroy Shermans at long range. In these moments, German crews felt a brief return of the old confidence. But these moments rarely lasted. American units responded with overwhelming coordination. Shermans that could not penetrate frontal armor maneuvered to flank. Smoke rounds obscured German optics. Artillery fell with increasing accuracy. Fighter bombers appeared overhead, forcing German tanks to either move or hide, often burning precious fuel in the process. The Shermans' ability to absorb punishment without immediately disappearing from the battlefield became critical. Tanks hit in non-lethal areas continued moving. Turrets jammed, radios damaged, optics shattered, but the hull rolled on. Even immobilized Shermans often remained active, their guns firing until silenced. German gunners began to notice something deeply unsettling. They were winning individual engagements and losing the battle at the same time. A knocked-out Sherman did not represent a permanent gain. A Panther lost to mechanical failure or fuel shortage did. Over weeks of continuous fighting, this imbalance became decisive. German armored strength dwindled not in dramatic last stands, but through attrition, small losses accumulating into collapse. By September, American armored columns had reached the German border. Many Shermans bore the marks of survival: patched armor, mismatched road wheels, replacement barrels. These tanks had been hit. So more than once, they had not been destroyed. German intelligence assessments now spoke openly of American armored superiority, not in terms of individual vehicles, but in operational endurance. The Sherman was described as adequate in combat and exceptionally reliable. The tone was no longer dismissive. It was resigned. The final realization came too late to change the outcome. The Sherman had never been designed to be the best tank in the world. It had been designed to fight a long war, and by the time German commanders fully understood this, the war was already moving beyond their ability to control. The battlefield no longer belonged to the tank with the thickest armor or the longest gun. It belonged to the force that could take a hit, keep moving, and return tomorrow and the day after that, as the front stabilized briefly before the next great push. The wreckage left behind told the story in steel and ash. German heavy tanks, formidable but stranded.
American Shermans, battered but advancing. The turning point had passed. What followed would be measured not in kilometers gained, but in consequences, for armies, for nations, and for the future of armored warfare itself. By the autumn of 1944, the balance of armored warfare in Western Europe had shifted decisively. The change was not marked by a single catastrophic German defeat, nor by the sudden disappearance of formidable enemy tanks from the battlefield.
Instead, it revealed itself in patterns loss reports, operational pauses, and the slow erosion of German armored strength. American armored divisions had suffered heavy losses. Thousands of Shermans were destroyed or damaged during the campaigns in France and Belgium. Crew casualties were significant, yet these losses did not translate into paralysis. Replacement tanks arrived steadily. Units rotated crews, absorbed reinforcements, and continued advancing. A division that had lost dozens of tanks in 1 week could still mount an offensive the next. German losses followed a different trajectory. Every Panther or Tiger destroyed represented a disproportionate blow. Production struggled to replace them. Transporting new tanks to the front became increasingly difficult under Allied bombing. Fuel shortages meant that even intact units could not maneuver effectively. A tank that could not move was as good as lost. Post-battle assessments within the German High Command began to reflect this reality. Reports acknowledged that American armored units maintained pressure even after suffering losses that would previously have forced a pause. German commanders noted the U.S. tanks were continually present and that destroyed vehicles were quickly replaced. This constancy had strategic effects. German defensive planning relied on counterattacks to restore shattered lines. These counterattacks required concentration of armored forces, something increasingly impossible. When German tanks did assemble, they faced overwhelming artillery and air power. The window for decisive action narrowed until it effectively closed. The Shermans' role in this outcome was both direct and indirect. Directly, it provided the physical means to advance, absorb losses, and hold ground. Indirectly, it embodied an approach to warfare that prioritized endurance over singular brilliance. American commanders planned operations assuming attrition, not avoiding it. The Sherman made that assumption viable. German soldiers on the ground felt the change acutely. Encounters with American armor no longer brought the expectation of easy victory. Instead, they brought the certainty of prolonged engagement, followed by artillery fire and renewed attack. Morale suffered accordingly. The myth of technical invincibility, cultivated during the early years of the war, was gone. By late 1944, German armored units were increasingly committed piecemeal, reacting to Allied initiatives rather than shaping them. The Battle of the Bulge would offer one final attempt to regain momentum. But even there, fuel shortages and mechanical failures limited the effectiveness of Germany's best remaining tanks. The Sherman, present in vast numbers during that winter offensive, continued to play its role not as an unstoppable machine, but as a reliable one. It advanced, it was hit, it was repaired or replaced, and it advanced again. As the fighting moved toward Germany's borders, the consequences of this imbalance became impossible to ignore. The strategic consequences of the Sherman's endurance became starkly evident as Allied forces crossed the Rhine in early 1945. German defenses, once formidable, now lacked the depth and flexibility to halt the advance. Even elite panzer units, equipped with Tigers and Panthers, could no longer respond effectively to the constant pressure of American armored formations. Each engagement highlighted the systemic advantages of U.S. production, logistics, and doctrine. Casualty figures, while sobering, reinforced this truth. Estimates indicate that approximately 4,000 Shermans were lost in France during 1944. Yet by December, over 2,500 had been repaired and returned to service. German losses were proportionally smaller in numbers but far more critical in operational impact. Panthers and Tigers destroyed were rarely replaced in time, leaving gaps in defensive lines that could not be filled. Fuel scarcity further immobilized heavy tanks, turning potent weapons into static obstacles. Veterans' accounts from both sides underscore the psychological shift. German soldiers recalled a sense of frustration and disbelief. Tanks they expected to be destroyed kept moving, returning fire, and supporting infantry. American crews described a growing confidence each hit survived, strengthened cohesion, hardened morale, and encouraged aggressive tactics. The battlefield became a test of endurance rather than raw firepower, a war of attrition at the operational level. Post-war analyses by military historians reinforced the lesson. The Sherman had not been the heaviest, the fastest, or the most powerful tank of the conflict. It was not invulnerable nor designed to be, but its reliability, numbers, and integration into a system that prioritized recovery, repair, and coordinated action allowed it to dominate in a way German heavy armor could not match. It had outlasted the enemy, not outgunned it. The American approach, the combination of industrial scale, logistical planning, and operational doctrine, shifted the paradigm of armored warfare. The Sherman was both a tool and a symbol, endurance over excellence, coordination over individual superiority, and systemic advantage over isolated technical achievement. By the end of the war, the German army's expectations about armored combat had been irrevocably altered. The Sherman had taught a difficult lesson. In industrialized total war, resilience, adaptability, and relentless pressure could outweigh superior firepower. It was not perfection that won, but persistence. And persistence had carried the Allied advance all the way to Berlin's gates. The stage was now set to step back and reflect on what this enduring, battered tank had truly meant for warfare and history. The M4 Sherman was never meant to be the most impressive tank on the battlefield. It was not a technical marvel, nor the embodiment of armored perfection. Yet, in the brutal calculus of World War II, it became one of the most effective. Its story is not one of singular dominance, but of systemic endurance, a machine that could be struck, damaged, and yet continue to advance again and again, as long as the war demanded it. The Sherman's success was rooted in philosophy as much as design. American military planners recognized that the battlefield was not won by isolated brilliance, but by sustainable operations. They built vehicles that were reliable, easily repairable, and produced in staggering numbers. They trained crews to survive, recover, and fight in unison. In doing so, they created a force capable of absorbing losses that would have crippled any other army and turning attrition into a strategic advantage. For the Germans, the experience was revelatory and, at times, disorienting. crews accustomed to technical superiority found themselves facing machines that, individually inferior, collectively imposed an unrelenting pressure. The psychological impact seeing tanks continue after direct hits, witnessing waves of reinforcements arrive without pause eroded confidence and reshapes tactical thinking. The war, it became clear, was no longer a contest of perfect weapons, but of systems, endurance, and human resolve. The lessons of the Sherman resonate beyond 1945. It illustrated that resilience, adaptability, and logistical mastery could outweigh raw firepower. It showed that in industrialized warfare, persistence often matters more than perfection, and it offered a human story of crews enduring trauma, of engineers repairing what seemed broken beyond hope, and of a military machine that kept rolling forward when everything around it tried to stop it. Ultimately, the Sherman's legacy is quiet but profound. It was a tank that survived because it had to, not because it was invincible. It changed the calculus of armored combat, influenced post-war tank design, and proved a simple, enduring truth. In war, survival and the ability to keep moving can be more decisive than any single strike. The battlefield remembers not just the firepower that fell, but the machines that refused to fall. And the Sherman, battered and scarred, will always roll forward in memory.